This is measure 1.2, perimeter. Perimeter is given the letter L. To measure the perimeter of a shape is to measure the length around the outside of the shape. It is one-dimensional, or 1D, and it is measured in meters, centimeters, millimeters, etc. And to calculate the perimeter of a shape, we add the individual lengths of all of the sides of the shape. So, for example, this shape here, to find its perimeter is to find how many units it takes to walk all around the outside of the shape, add the individual sides, and the answer in this case is 27. Quadrilaterals. The quadrilaterals are four-sided shapes such as squares. Points of information: all four sides of a square are equal. So to calculate the perimeter, you just need to know one of those sides. In this case, the sides of this square are 9, and 4 9s are 36. That gives the perimeter. Opposite sides of rectangles are equal. So in this case, the right is 5, so left will also be 5. Top is 12, so bottom will also be 12. To find the perimeter, you will add 2 12s and 2 5s, and you will get 34. Similarly, opposite sides of parallelograms are equal. Of course, the rectangle is also a parallelogram. In this case, you have two sides. The slope sides are both 6, and the horizontal sides, the top and the bottom, are both 10. So adding those four sides, you get 36. Triangles. Equilateral triangles have 3 equal sides. So the word equilateral, equi means equal and lateral refers to the sides. They have 3 equal sides like this. This one here has side 10. The markings on the sides indicate to the reader that all 3 sides are equal. So the perimeter of that triangle is 10, 10 and 10, or 30. Isosceles triangles have 2 equal sides, such as this one. It has a base of 8 and 2 sides of 15, so its perimeter is 38. And the markings indicate that the sides are equal. A scalene triangle has 3 different sides, so none of them are the same. And to find their perimeter, you must know or be given the information on how long are each of the 3 sides, and you add them. You get 42 for that one there. Now we move on to area. Area. So the area of a shape is how much surface it covers. It's a measure of two-dimensional space, and it is flat. So if you look at the top of a desk or a table, what size is that? What is that flat surface? It is measured in meters squared, centimeters squared, millimeters squared, etc. And to calculate the area of a shape, we must have 2 dimensions, and we multiply them. For example, length times width. So let's take this rectangle. It's a quadrilateral. We can calculate the perimeter, so it's 3 on the sides and 5 on the top and bottom. Okay, 5 units. And so the length or the perimeter, when you add those 4 sides, is 16 centimeters. But what about its area? Okay, given that it's 3 high and 5 wide. So you could start by counting the individual unit squares. And if you count those, you'll find that there are 15 unit squares. Or we could take them in groups. If we look at the columns of 3, we could count the columns of 3. So 1 column is 3, 2 columns is 6, 3 is 9, next makes 12, and finally we get to 15. Okay, so what are we doing there when we're counting in groups? We're taking groups of 3 and we did 3 times 5. Okay, so that's 2 dimensions. That rectangle is 3 high and 5 wide. So 3 times 5 equals 15 centimeters squared if each of those squares is a centimeter in measure. And we say that the area is 15 centimeters squared. So quadrilaterals, we just saw an example there. Squares, we can get the area of a square by multiplying its length by a width, like the previous slide. We know that squares have the same length and same width. So this one is 9 times 9, we get area 81. Rectangles, again, area is length by width. This example is 12 times 5. Okay, so the area of that is 60. Parallelograms. Okay, the area of parallelogram is not 10 by 6. That would give a rectangle which would be straight up, so the sides would be vertical. When the parallelogram becomes sloped, or you take the rectangle and you stretch it, the area is reduced. Okay, so it will be a smaller area than a rectangle of the same dimensions. The formula for the area of a parallelogram is a length, so that's one side, by the perpendicular height. So that new symbol there looks like an upside down T, means perpendicular, and perpendicular means at right angles, so when 2 lines meet at 90 degrees. Okay, so if we look at our picture here, the 10 on the top or the 10 on the bottom is going to be my length, and the perpendicular height will be the height straight up and down from those, meeting them at 90 degrees, and this one gives the measurement as 5, so that's what you use, not the 6. So 10 fives are 50, that's the area there. If you look to your formula tables book, which is provided for your exam, you'll find information on the parallelogram there. Okay, so you don't have to remember this as such, but it does look slightly different. Here's area. Area equals AH. Okay, where A is shown here as a baseline and H is the height straight up. Okay. Triangles. Let's start with the rectangle here. We know from the previous slide that the area is length by width. Just for our purposes here, I'm going to change the names of those measurements to base by perpendicular height. So let's take the length as being the base and the width as the perpendicular height. Okay, now let's cut this rectangle in two, and it's divided into 2 equal halves. What have we created but 2 equal triangles? Okay, and the area of one of those triangles is equal to half of that of the rectangle we just had. So the area of a triangle is half the base by the perpendicular height. And the bases here are the black lines, and the height are the lines, the black lines meeting them at 90 degrees. So we don't use the red line at all. That's not perpendicular to either. The same is true for any triangle that's made out of that same rectangle. Okay, that triangle there has the same area as the others. You use half the base by the perpendicular height, and indeed a triangle like this has the same area as well. Okay, so here's my base. Okay, but the perpendicular height must be measured externally or outside. Okay, so you continue whatever you're using as a base, and you draw a perpendicular line up to the highest point, and that will give you the perpendicular height. It's going to be the same height as the original rectangle. Okay, now let's get the area of this triangle. Okay, firstly we have measurements of 10, that's a base, but 13 is not perpendicular. We need that perpendicular height that's shown there, the line that's straight up vertical. Okay, we need that perpendicular height. And we're going to use Pythagoras' theorem to get it. We're going to focus on 1/2 of the triangle, okay, and that contains a right angle. Okay, so instead of 10, I'm using 5. So we're only going to use, let's say, the right-hand side. So that's 5. B, I'm going to call H for height, perpendicular height. And 13 is a hypotenuse. Okay, so we can use Pythagoras' theorem to solve that. When you work out all the numbers, that height is 12. Now, once you have that, you can use your area of the triangle formula. Your base will be the full 10 and the height is 12. So you get A is half 10 by 12. You could say A is half of 120, which is 60, or half of 10 is 5 times 12 is also 60, okay? Or you can use 0.5 instead of the half on your calculator. There's information on the triangle in your formula books as well. Here it is. Area, you see here, is half AH. A is this baseline, and H is the perpendicular height there.